Hello again, students. This is Mr. Parrish. Today I'll be talking through the current atomic model. So this is for your quiz on Wednesday. I figured the best way to do this would be to sort of go through what we go through in class. And that is going to be the PowerPoint that I made on modern atomic theory. If you'd like to follow along, you can fill in the notes on page 3 and 4. Both of all the slides, you'll have space on your notes to fill in. So this is the first diagram we're looking at. It's the development of the current atomic model. So what are the components of the current atomic model? There's 5 major components. The first would be that the whole atom itself is composed of protons, neutrons, and electrons. We've talked about these before, so hopefully you remember that protons have a positive charge, neutrons have a neutral charge, and electrons are really small and have the negative charge. Okay. The positively charged nucleus, that's where the protons and the neutrons exist. So right there in the middle of the nucleus. Most of the atom is mostly empty space. That's because the electrons are so small that they don't take up a lot of the space in the atom. And the electrons are not in the nucleus, they're mostly around the nucleus. The negatively charged electron cloud, it's negative because electrons are negative themselves. We call it a cloud because we're not really sure where the electrons are located. It's kind of our best guess. Most probable location of the electrons is in the electron cloud. So, like I was saying, electrons are really small, they're really fast, and really hard to trace. So, we're not really sure where they are, but we kind of have a structure for where they are, and we're going to talk more about that later this week. This is a timeline of the current atomic model. So, you can see it's kind of structured like the handout that I gave you. 450 BC is the first person who came out with the idea of an atom. His name was Democritus. He proposed the idea that we're all made up of these things called atoms. It took a long time, but around 1802 is when we started discussing the theory of the modern atomic theory. 1897 is the discovery of the electron. We're going to talk more about detail of these discoveries in a second. The discovery of the nucleus happened in 1911, so that's when they discovered that there was a densely positively charged nucleus in the middle of the atom. And the discovery of the proton happened here in 1912. So as you can see, the 1910s, or pretty much the turn of the century to 1930 was a pretty exciting time in quantum mechanics. The neutron wasn't discovered until a few years after 1930, so this timeline is pretty much review. You guys have a timeline in front of you, so you shouldn't really need this information. This is Dalton's atomic theory. So Dalton was one of the first scientists to really come up with a theory on atoms besides Democritus. Okay, and he had 4 postulates, and these are the 4 postulates. And postulates is just a fancy word for rules. So you can fill this in on page 4 next to Dalton. So you can see his 4 postulates there. Okay. Now, later we discovered that not all of these postulates are true. So I'm going to let you read these postulates on your own and kind of come up with your own idea of what Dalton's ideas were. But the 2 that are untrue are postulate 1 and postulate 3. Atoms are small, indivisible, and indestructible particles. We know that's not true, right? They are not indivisible. They are not indestructible. Okay, they can be all atoms of a given element are exactly alike. We know that all atoms of a different element are different. Okay, so we know that, we know that because of isotopes, different atoms have different neutrons, right? So they're not all identical. There's different amounts. Okay, so what was wrong? These are the wrong parts, okay? All atoms are small, indivisible, and indestructible, and all atoms of a given element are exactly alike. So those 2 are wrong. So you can see right there at the top of page 4, there's space for you to write down what is wrong. So you can kind of pause the video and take those down. I'm going to keep moving here. Okay, so we know, so this is what exactly is wrong. We know that the existence of protons, neutrons, and electrons are what make up atoms. So atoms are built on even smaller parts called subatomic particles, protons, neutrons, and electrons. And here, like I was describing earlier, isotopes do exist, and so they differ with the number of neutrons and their mass. So if you're looking for what's wrong, take a good look at this slide. Okay, looking at Thomson's experiment. This is the cathode ray tube. This is actually a primitive version of how televisions work. He was the guy who discovered the electron. Okay, so basically with this experiment here, he had a cathode emitting electrons, and he had a positively charged plate and a negatively charged plate, and he shot these electrons through this beam, and he found that the beam bent towards the positive side. So that's how he knew that electrons were negatively charged, because they were attracted to the positive side and repelled from the negative side. Okay? He experimented with cathode ray tubes, so you just need to associate the idea of a cathode ray tube with Thomson. And he created what is called the plum pudding model. So he had no idea there was a nucleus, but he knew that there were electrons. So he had an atom with electrons kind of plumped in there like plums in a plum pudding. I've never eaten plum pudding, but I assume it's a pudding with plums on top. So I guess that's what his sort of vision of it was. How long are we into the video now?
5 minutes.
Okay,
5 minutes,
so here's what I'm going to do. So I've gone through Dalton and Thomson. Tomorrow I will go through Rutherford, Bohr, and Schrodinger. So that way you guys only have to watch one video tonight, and tomorrow I'll make another one for the rest of it. Okay, have a good night. Let me know if you have any questions tomorrow. You should fill in at least a little bit of your timeline and answered a few questions for yourself. But besides that, let me know if you have any questions tomorrow. Thanks and have a great night.